Okay, so here's a quick tutorial video on how the moon affects the tides of Earth. Now, what a lot of people don't realise is also the gravitational influence of the sun. Now, this is a picture that I drew in paint, well, rather a picture that I drew with Crayola pens and then scanned it onto my computer, so forgive me for the quality. But the sun itself is 400 times bigger than the moon, but yet it is 400 times further away, which means that essentially it does influence the same gravitational force that the moon does on the tides, but because it's so much further away, people often ignore the idea of it. People are in tune with the fact that the sun exerts a gravitational force on the Earth which keeps it in orbit around the sun, but people don't really know that it does actually affect the tides as well as. Now, of course, the moon takes roughly 28 days to orbit around our planet, and with that it actually drags the water with it pretty much. But the key point to note is when the moon is in specific positions, we'll have high tides, and when it is in other specific positions, we'll have neap tides. So let's get the less familiar out of the way. For neap tides, the moon would need to be here and here. Now, why the tides are so low is because, also remember, we have the sun, which is exerting a gravitational force on the oceans, which if I draw this, I'll pick blue because that's typically the colour of the ocean because it's got oxygen in it. There you go. The moon is exerting a force on these oceans, sorry, the sun is exerting a force on these oceans, and it is always pulling it towards it, and the sun never moves. As you all know, we orbit the sun. Now, but because we have the moon here, pick another colour, the moon too is pulling the tides this way, or whether it be here, it be pulling it this way. So what this does is it actually cancels out the gravitational force of the sun, and also the sun cancels out the gravitational force of the moon, because they are equally trying to pull the oceans towards them. So what we get effectively are neap tides, we get low tides, because there is no victor. It is an equal tug of war. Whereas if the moon was here and here, it will be exerting a force on our oceans that is essentially, although they are pulling the oceans in different directions, particularly with this case here, I'll show you what will happen. Because the sun is going to be pulling the oceans this way and the moon will be pulling the oceans this way, you get a tidal bulge effectively, which would look something like that. And what's happening is, effectively, if you can imagine that we have a giant sphere of water. Forget all the land for 1 second, just picture that the Earth is a giant sphere of water, and what is happening is the moon is pulling the water this way, the sun is pulling the water this way, and it turns it from a sphere into a rugby ball, and this actually causes high tides in these two given places. But obviously we will get high tides all the way around these coastal areas. And what happens is, essentially as well, if we were to get the moon in this position, it would be pulling effectively the oceans even greater, so we may even get a greater bulge, but we would also get one on this side because it would shape the water. Effectively it will be turning the water from this into this, constantly squashing it, pulling it backwards and forwards all the time, purely through the force of gravity. Which is amazing, considering the fact that although effectively the ratio of the size of the sun and the moon work in tangent with each other, they have a similar gravitational effect. The moon is actually 250,000 miles away. Let's see if I can write that down. So excuse me writing this in paint. 250,000 miles away, and the sun is a mighty 93 million miles from the planet. So effectively that also brings into the idea how long range gravity is. Gravity has an infinite range. It can affect anything in the universe, and consequently I think gravity, or rather everything, every little piece of matter has a gravitational effect on everything else. And that pretty much concludes the video on the tides. Thank you very much.